So, welcome back, students, in the Unit-3 multiple linear integration model. And we have seen in the last class how the multiple linear regression works, some applications, and discussed few linear and non-linear regression model. And now we will discuss linear regression model with two explanatory variables, and I think we have started the session. The model is now in front of you, and yi is equal to beta naught beta 1 x1 I plus beta 2 x2 I, and you can call ui. So based on the expectation, one can get the expected value of yi, and once you get expected value of yi, you can find ei. You can find ei, and that ei is your error value. And since the ordinary least square estimator says that if you want to get these parameters, you need to minimize the error. Okay? If you want to get this parameter, you should minimize the error sum of square. So that's why we have to minimize the error sum of square, and assuming e will be summation of ei square, because error sum of square. So we need to do sum and their square. So error sum of square, and then to get the parameter we have to differentiate with respect to the respective parameters. This is the one condition, and second condition, your second derivative should be positive. See, always when we check for minimization or maximization, this is a very bad habit that we never check the second derivative. Okay, that's a very bad habit. Even if you have seen the last class, it happens. Okay, but because we assume that the second derivative will be the positive. So for minimization condition, you need to check the both the conditions. You need to check the both the conditions, first derivative and second derivative. Since we assume that second derivative is positive, therefore one can get the value of beta 1, beta 2, beta. So if I differentiate with respect to beta naught, I may turns out to be this beta naught value. Similarly, when I differentiate with respect to beta 1, I may get this expression, and similarly beta 2 will get this expression. Now our aim is to be estimate beta naught, beta 1, beta 2. Okay. So what I'll do, I have already beta naught ka value here. Okay. So what I do now, I will substitute this value of beta naught in my equation 2. Okay. So let's begin now. So, I hope you can able to see the screen.
Yes, sir.
Okay. So substitute value of beta naught hat in equation 2, and we get summation yi x1I is equal to, so here we have to replace it by the beta naught ka value, which is y bar minus beta 1 hat x1 bar minus beta 2 hat x2 bar in the bracket, and we have this summation as it is. So it is sum over I, which is running from 1 to n, x1I plus this beta 1 will be as it is. Make sure that this is I. So first one will be numerical number and second one will be your I. Now you can get simplify these expressions. So if you just simplify the expressions, so this is equal to take all betas together and take without beta will be together. So I can take this term. So this is summation yi x1I, and if you multiply by this with this and take it to left hand side, it will be y bar summation x1I, right? So this term now goes away. Now you have to club that beta 1 term together. Okay, so if you see these expressions I have here, club this with this star with this star. Okay, so it contain beta 1, it contain beta 1. So this is going to be beta 1 hat, okay, and this is the minus sign, this is the plus sign, right? This is the minus sign, this is the plus sign. So I will take beta 1 here, and then it will be summation x1 I square minus x1 bar into this term because it is in bracket, right? So x1 I plus, now take beta 2 term. So it is going to be beta 2, again it is in minus, so I will take first positive term. So it is summation x1I x2I minus x2 bar summation x1I. I hope this will be okay for you, because I just skip the one step which is very common. You can just open the bracket and then club together, okay? Because the derivation become lengthy if you just include all extra terms, okay? That is not necessary, so you can skip the few terms, okay? Sorry. And we are something knowing about this term. What is your x1 bar? What is your x1 bar? X1 bar is equal to summation x1I upon n. So what I will do here now, I will replace this summation x1I is equal to n into x1 bar, right? And similarly I will say summation x2I is equal to n x bar x2 bar, right? So I will just going to replace these quantities in this expression. So it is now therefore summation yi x1I minus y bar summation x1I is equal to beta 1 hat summation x1I square minus x1 bar, and this quantity will be replaced by n into x1 bar plus beta 2 hat, and again this quantity we cannot replace because this is in the form of multiplication, so keep as it is. Summation x1 bar x2I minus x2 bar, and this quantity will be replaced by right, there is no correction, n into x1 bar. Therefore what we can, even you can do this one replaced, right? So I just keep left hand side also replace. So this is going to be uh, n into x1 bar. Okay, now just make some simplified term. So if I do this, this is turns out to be summation yi x1I minus uh, I will write this as nothing but n x1 bar y bar, and this is your beta 1 hat, and this is summation x1I square minus n into x1 bar square plus beta 2 hat summation 1I x2I minus n. I think this we cannot do anything, so we can just keep it in order. Okay, now we know that maybe you're familiar with these terms. This is summation x1I minus x1 bar yi minus y bar. This is equal to summation x1I yi minus n x1 bar y bar. This is equal to summation x1I small y bar, or small y bar, this I can take yi. This is yi. And similarly summation x1I minus x1 bar is equal to summation x1I square minus n x1 bar square is equal to summation x1I square, and summation x1I minus x1 bar x2I minus x2 bar is equal to summation x1I minus into x2I minus n into x1 bar into x2 bar. This is again equal to summation x1I x2I. So I hope you are clear with these expressions. This is something like covariance of formula which we are using, right? And that is simplified form. It is like your variance ka the numerator term. It's like a variance ka numerator term. One can write if we have given the data of sum of the difference between your given observation and their mean, one can return as like this also, right? So that expression I'm using because I'm going to replace these quantities by simplified form. Okay. Is any difficulty in writing this? We know that these expressions. See, this expression is based on given these values. So here we have x1i, x2i. That's why I'm using the covariance term. Okay, because it is nothing but covariance term. Similarly, here we have a covariance term because it is something xy minus n into x1 bar y bar. Okay, this is like covariance term. Okay, anyone having any difficulty relating to this one? Because this is something expression which we have to be understand, and then based on that you can go ahead. Okay, no one, so we can proceed. So this is basic terms which we can use it for or we can use it for replacing the quantities, because these expressions are very lengthy. Okay, so one can replace directly by uh, given expressions to simplify your beta 1 beta. Okay, now where 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 you can see here where this x1i is equal to this x1i is equal to, okay, so this x1i is equal to, I'm writing here, so this is nothing but x1i minus x1 bar, and yi is equal to yi minus y bar, and x2i is equal to x2i minus x bar. Since I'm using these expressions and I'm replacing this quantity by this simple number, okay, this number you need to calculate using calculator, which is the difference of these quantities, right? And then you can do the summation, you will get the entire quantity. Okay, so now therefore what could be your expressions now based on these notations? So if you just see the expressions, your left hand side is nothing but, left hand side is this, right? And left hand side is this expression. So if I replace this quantity by this one, I may get summation x1i yi is equal to beta 1 hat summation, because this quantity is your second one, so x1i square plus beta 2 hat summation x1i x2i. Say this expression is, so this expression is 4. This one is, this one is 4. Okay, so now this similarly we have to do it for, substituting the beta naught value in the equation number 3. Okay, similarly So I may go for spin only. So you can say similarly substitute value of beta naught hat in equation number 3. So now we have substituted in equation number 2. Can you see here? We have substituted the equation number 2. I have equation number 1, 2, 3. So first step is that after computing 1, 2, 3, you need to substitute the value beta naught. 1, you have to substitute in 2. Similarly, 1, you have to substitute in 3. Okay. So if you substitute directly 1 and 2 in that expressions, so since I have written similarly, because the entire thing you have to just substitute as it is. Okay. So uh, can I leave it for you to substitute? You can work out.
Yes, sir.
Yeah.
Yes, sir.
So majority is saying yes. I think majority is okay with you. It is just matter of writing the few steps. Babo, slowly. Sorry. Uh, so it is just matter of substituting the values. So you can see how many steps are there in that equation number 3. So I'll just explain a little bit. If you substitute this expression, it is now in terms of x2, right? It is in terms of x2. So all notations and everything, all the steps are absolutely as it is. If you just go through that, what is going to be changed in these expressions, that we can see directly. So similarly, if you substitute the beta naught in equation number 3, you may turns out to be summation. Now based on this, we can write, right? So this is going to be x2i yi is equal to, instead of, now you can see beta 2 के time पे we have the covariance term. So similarly beta 1 के time पे now we have a covariance term. So x1i x2i plus beta 2 hat summation x2i square. See, in this expression we have a beta 1 के time पे we have a x1i square, but we are substituting in in 3. That's why in beta 2 के time we have the variance term. So this is going to be expression number. Let me check this expression. So summation x1i summation x2i plus beta 2 hat xi square. Okay, fine. And I is running from 1 to n. I is running from 1 to n. Similarly here also we have I is running from 1 to n. 1 to. Everywhere we are putting I is running from 1 to n. So this expression is number, this is 4. Sorry, this is 5th one. Is it okay to all now? This expression, I hope you can understand how one can derive. So now, what you have to do here, you can see we have now the standard equations. Like you have a beta 1 and some expression, beta 2 some expressions. Similarly, beta 1, beta 2. It is something like you can say 20 is equal to 5x1 5x2, like that expression. Means you can, it is very simple like expressions. Okay, so can we simplify these two expressions 4 and 5 simultaneously and get the value of beta 1 and beta 2? Anyone can tell? Can we simplify the equation number 4 and 5 and we can get the value of, since beta naught we have already, we need to get the value of get the estimate of beta 1 and beta 2. Yes, what we will do here, you can see in beta 1 hat we have summation x1I square, right? And here we have summation x1I and x2I. If I get multiply equation number 4, or I can do it in different way. We need to make the one parameter coefficient same. So either you multiply this expression by x squared to I, okay, x squared to I, and this expression by summation x I1 and x I2. Can the coefficient is going to be same? Can the coefficient is going to be same?
Hello, sir.
हाँ बोलिए.
Sir, we multiply in question number 4 by x2I and in and equation 5 we multiply by x1I.
x1I square or x1I x2I.
In equation number 4 we multiply by
Hmm.
x2I and in equation 5 we multiply by x1I.
Okay, so let me write it down. In equation number 3, sorry,
4
equation number 4, in equation number 4, we are multiplying by equation number 4 multiplied by you are multiplying just a minute, I'm selecting it. Just a minute. summation x, no, it's not capital X, it's going to be small. This is small x to I square, and equation number 5 multiplied by summation x 1I x 2I. Let's see whether it works or not. So if I multiply by equation number 4 by this quantity x 2I, so what will be expression? So this is going to be summation x1I yi into summation x2I square is equal to beta 1 hat summation x 1I square into summation x 2I square plus beta 1 hat summation x 1I x 2I into summation x 2I square. Now you multiply in equation number 5 by this quantity. We get, therefore, x2I yi into summation x1I x2I and this is beta 1 hat, and you can see this is the summation x1I and x2I. So this is same, right? So this is going to be become square. So x1I x2I, let me multiply and then we'll do the next step. 1I x2I plus beta 2 hat summation x2I. Let me know if anywhere I am just doing any mistakes. Let me know, because x2I. Okay. So say this expression is we don't have any color here. Say this is 5 by 6 and say this is 7. Yes. Have you understood the equation number 6 and 7? Then let me know first. Because your entire expression now, do 6 minus 7. Equation 6 minus equation 7. Okay. So if you just do the equation number 6 with 7, equation number 6 subtract with equation number 7. So if you just do the subtraction, the left hand side become summation x1I yi into x2I square minus summation x2I yi summation x1I x2I. This is the left hand side. Can you see any expression or any term is common here which we can get cancelled? Any expressions? This is not plus, this is minus. So it can confuse. This is minus. Now this is plus I. Yeah, it is plus. So if you see this term, the first term, I think this is beta 2.
हेलो सर.
Yes, बोलिए.
सर इक्वेशन नंबर 6 में उधर हाँ बराबर बराबर बीटा 2.
Beta 2. That's why I'm wondering where is my like beta 1 is there, beta 2 is not there. Okay. I think there also I've written the same thing. No, it is beta. Okay. So if you see there now, uh, this expression number 6, this will goes away because it has the same term. Correct? So now remaining is this much. This is going to be, if I take common beta 1, so beta 1 hat is equal to summation x 1 I square summation x 2 I square minus summation x 1 I x 2 I a whole square,
Oh.
right?
Yes.
Okay. Now based on this expression, one can get beta 1, which is going to be, summation x 1 I yi summation x 2 I square minus summation. It's very big expression, but we don't have any choice. Now you can take, if I have not replaced that difference wala part, then this equation is like writing, it's very difficult. अभी इतना बड़ा है तो पहले कितना बड़ा होता, you can just imagine. So this is the, yes. Now let me know if you have uh, any difficulty. So now we have finished the half part of derivations. थोड़ा सा डिफरेंट वे में इसको ही करना पड़ेगा. Anyway, okay. Anyways, I'll not put the rectangle because it will take the reverse. We'll cut the expression. No problem. Okay. So any difficulty in this expression now? This expression so far. I'll scroll it. If you have any questions, then let me know. Because similar fashion you will be get the beta 2. Similar fashion you will get the beta 2. Now if you want get beta 2, what is going to be do simplification? Can you tell me anything? Anybody? Using expression number, say, uh, you have multiplied equation number 4 by this quantity, right? Now you multiply equation number 4 by this quantity. So if you multiply, means reverse multiplication, okay? So in equation number 4, so again same thing. Similarly, equation number 4, in equation number, let me start once again. I hope you are all writing the same thing, not just listening and watching the things. if if you will be write it down, you will be clear. Otherwise you may be clear watching this video as well as things. So equation number 4, if you multiply by summation x1I and x2I, and equation number 5 by summation x1I square. See, if you multiply equation number 4 by this term, and it is very simple to understand when we multiply with what. इसका जो coefficient है ये है, you multiply will be here, and इसका जो coefficient you multiply by here. तो देखोगे तो इसका coefficient same हो जाएगा. Similar, I did same thing. I multiply this equation का coefficient with this here and इसका coefficient here. तो ये coefficient same हो गया and it will get cancelled and turns out to be beta 1. Similarly इसका same करना है तो इसका coefficient से multiply करो, you will get the beta 2. So you can just work out this, and once you work out you will be get the equation number. I just leave some space for the to get the equation number 8 and 9 I think. So you will get 8 and 9. So I'll leave the space for you. You can fill it this, and then what is my step? Equation number you can call subtract. What now you have to subtract from equation number 9 to equation number 8. Only difference is this much, because otherwise you get the negative sign and you have to do a little bit here and there. So what could be the expression now? Therefore beta 2 is going to be beta 2 is going to be beta 2 hat is going to be, it is summation. See the expression what I'm writing, it is going to be almost same, almost same. So wherever there is a we have multiply x2 now we have to multiply x1. Okay, so that much change is going to be there. So it is going to be x2I yi and summation x1I square. So can you see here, wherever my 1 I am replacing by 2, wherever my 2 I am replacing by 1. I think this is going to be same, because when you replace 1 by 2, 2 by 1, it is going to be same. So this is going to be x1I yi and summation x1I x2I. Can you see here, in this expression when you replace 1 by 2, 2 by 1, it is going to be not, it is not going to be effect. So you can get that whole thing divided by what is that, summation x1I square summation x2I square just give me a minute. So based on the above expression you may get this x1I x2I, this is going to be same only. I hope you are clear with this. Okay, so I'll stop here. If you have any query you can talk. Yes. So this is the beta 2 expressions. So let me know if you have any query here. Let me see the chat box. हम्म, मेरा डेटा विजुअलाइजेशन का असाइनमेंट के पहले जो एमपी वीडियो है वो ओपन नहीं हो रहा. डेटा विजुअलाइजेशन के एम रोशन, I think the video should work. Videos, Roshan is there?
Yes,
Yeah, I think it is working. There is no problem at all. Maybe you can. Mm,
वो बता रहा है कि दिस आइटम इज यूज्ड बाय यू. नेक्स्ट असाइनमेंट में जब सबमिट करने जा रहा हो तो वो असाइनमेंट लॉग्ड बता रहा है.
असाइनमेंट लॉग बता रहा है.
यस सर.
I think ऐसा नहीं होना चाहिए because I think data visualization is it last part? It is last.
यस सर, यस सर. लास्ट डेटा विजुअलाइजेशन वाला 1.554
Yeah,
समथिंग.
yeah, 1.5. Correct. Because before that we have a data manipulation assignment and then we have data visualization. I think it should not work like that because maybe there's some technical issue will be there. So you can just send me the pic of that. I will try to
यस
rectify
सर,
that.
यस सर, यस सर.
I think one student has already completed the task, so that I will discuss in the next session. So let me see if we have any other queries there. Yes,
Hello, sir.
yes, बोलिए.
Can you again show the screen onwards, starting onwards?
Yeah, definitely. Starting means today lectures, na?
No, sir. From starting, last from previous lecture.
This one.
Yes, sir.
Okay. So you are all writing or you just want to watch this?
I just want to watch this again.
Okay. So let me know when I'm just going to scroll it. See, the steps is very simple. You need to just calculate EI and understand EI का meaning क्या होता है. It is minimizing error sum of square. And once you take error sum of square, now the rest task will be very simple. Differentiate with respect to beta naught. You will get some expression, that is say call 1. Then differentiate with respect to beta 2, call 2, beta 3, call 3, beta 2, call 3. And then task starting from your beta naught. So make sure that all beta naught, beta 1, beta 2 expressions must be correct. Otherwise, even if the single things will be going to wrong, the whole thing will be the wrong. Are you getting my point? Because it is all interrelated. So substitute beta naught ka value in equation number 2, we'll get next expression, which is equation number 4. And again substitute the beta naught ka value in equation number 3, we'll get the equation number 5. So I'm using the equations. So once you substitute, you'll get equation number 4. Similarly, one can get equation number 5. Now the task is very simple. You simplify these two statements, means get simultaneously. So coefficient इसका same कर दो आप. You multiply this with this quantity, this equation, and this coefficient with this quantity. Beta 1 same हो जाएगा, beta 2 मिल जाएगा. Similarly, reverse way. Okay. So this is your beta 1, this is your beta. Just make sure that कि आपका expression जब आप simplify करोगे तो आपको यही मिलना चाहिए. मतलब इससे अलग नहीं मिलना चाहिए. You will get this expression. So you can have a 5 minutes break. We'll meet in 5 minutes. By the time you can see if you have any query and you can fill this. If you don't want to go for the break, you can just fill these two expressions. Okay, I'm coming in 5 minutes. So welcome back, students. All are there. We can wait for 1 2 minutes. So we'll start the session in 1 minute. Yes. So I'll share the screen of. I will not share the screen of this is canvas. I hope the Rinku Yadav. Rinku Yadav is there. Rinku Yadav is there. Shubham. Shubham is there on. Yeah. Rinku Yadav has successfully completed his Unit 1 assignment and well as quiz with with total scoring marks is 78%. Congratulations. And Shubham Balikaran, I cannot say entire name. Shubham Balikaran Round has completed his assignment successfully with 90%. Oh, great. Congratulations. Nitin Upadhyay completed their quiz and assignment with 85%. And so far, the highest marks obtained among all the students is Yes Upadhyay with 92%, and 92 point something is there, 92.5%. And even the same thing Ashish Rana has also scored same thing, 92.5%. So there is tie up between Yash Upadhyay and Ashish Kumar Rana. So far, congratulations these students. They have successfully completed their Unit 1 all quiz and assignment. And very soon I'm going to announce few more name. I hope. Okay. So it's very good for like if you're doing like all other than teaching part. Okay. This is something like you are. It is something like see. It is not a paid version. Even if you enroll for eh, any other course, you have to do a lot of things. But here you have to just submit your email ID and you have register for the course, and you can start working on entire material. Okay, so it is very good thing. The other students can also. I think everybody got the mail yesterday, so they can just look at the mail and they can proceed and try to finish it at least maybe in this month you can finish this unit. Okay, if possible, because today is 26. It is not possible to complete in 4 or 5 days, but still maybe the next month you take uh, between, I can say, October mid. October mid, by the time you can finish this unit, that will be good. And I'm working on the next unit. I'm working on the next unit, and if possible, I'll try to create a few quiz and assignment. But one thing just I want to tell you in that scenario, because in these units there are very few things, very few theory part, and more about all derivations. So creating a quiz and everything is quite difficult in terms of mathematical notations. So, but if possible, I will at least try to see one or two quiz based on the remaining unit, so that you can uh, understand the unit and how you can summarize the unit. Okay. See, performing a quiz and assignment is just like we are understanding the theory and then we are moving to the quiz and that, because entire quiz will cover the entire theory part. See, it's not like that you will not study the theory part, and when you directly perform the quiz, then definitely I'm sure with that your score will be the down. Your score will be that absolutely down. But if you do little bit the theory, just go through, even just have a look, and then if you just try to solve the quiz, excellent, you will be do better than previous one. Anyways, so congratulations to everyone who has just successfully completed their Unit 1 quiz and assignment. And I hope I will announce few more name in maybe in 2 3, maybe in this week. Okay, so let's begin. Uh, I have already shared the screen. See in your canvas, at last there is a feedback form, and once you have completed the unit 1, I think I have just maybe moved little bit down that feedback form, because I thought let me take it up first. But so once you have completed that all quiz, maybe assignment, at the last you have that your feedback form. So you need to fill that form. Okay, then only you can move to the next unit, because that is all locked system. Okay, so I hope it is clear to everyone that all we have seen the derivation today, and I hope I'm not going very fast. Yeah, even I have skipped some part, but that that is need, that is required, because if I given everything on the screen, then you're just going to rely on the screen. You're not going to, means you will be not like brush it your brain. Okay, so you must get the some time to maybe writing or maybe calculating the new things. So that's why I just skip few things, but it is not very difficult task. One can with a small knowledge one can write it down. Okay, let's start. Okay, so I think some background voice is coming, so you can uh, please mute yourself if uh, okay. So let us begin. So now, okay, I'll take out my pen. So for two explanatory variable, for two explanatory variable, regression model, it can be it can be proved that it can be proved that explain sum of square explain sum of squares, in bracket I can call ESS, is given by is given by so it can be proved that ESS is equal to ESS is equal to beta 1 hat summation x 1 I yi plus beta 2 hat x 2 I yi. So I think this expression we have found somewhere. Okay. And also, and it can be proved that it can be proved that for total sum of square, degree of freedom is going to be, and can you tell me the total degree of freedom?
n minus 1.
Correct. So it is n minus 1. And for ESS, degree of freedom, this is due to regression, is going to be 2. How it is 2? Hence, hence for RSS. What is RSS?
Residual sum of square.
Okay. Residual sum of square, which is n minus 3, or is it residual or it is a regression? Residual or regression?
Residual.
Residual. Therefore, MRSS. What is MRSS? What is MRSS? Mean residual sum of square, which is equal to regression sum of square upon degree of freedom. So regression sum of square is it is summation of EI square, whole thing divided by n minus 3. Now which is unbiased estimator of sigma square. Therefore, sigma hat square is equal to MRSS equal to RSS upon n minus 3, or I will write summation of E square upon n minus 3. Now what will be the coefficient of regression? Coefficient of determination, which we called R square, is given by, what could be that? R square. What is the value of R square? It is ESS upon RSS. Right? ESS upon RSS. So we have ESS, which is beta 1 hat summation x 1I yi plus beta 2 hat x 2I yi, whole thing divided by summation of TSS yi square. So what is ESS here? R square into TSS, and RSS summation yi square minus R square summation of yi square equal to 1 minus R square summation of yi. So let's take recap. So this ESS can be obtained. Beta 1 hat we need to calculate using this formula, and summation of x1 I yi beta 2 hat summation x2 I yi. Now we know that total degree of freedom is n minus 1. Okay, and we have the regression due to regression. How many parameter we have? 3: beta 0, beta 1, beta 2, right? So it is 3 minus 1, which is going to be 2, right? That's why it is 2. So 3 minus 1 become 2. So to get the degree of freedom for RSS, it is going to be this total minus regression. It is turns out to be n minus 3, right? And we know mean regression sum of square can be obtained using RSS upon degree of freedom. RSS upon degree of freedom. So residual sum of square is nothing but summation ai square upon n minus 3. And we know that is unbiased estimator, so one can write directly. But what is coefficient of determination? Which is r square, which is ESS upon RSS. Okay, which is ESS upon RSS. So ESS expression we have already. RSS is a residual sum of square, which is yi square. Now from where yi square comes here? Sorry, this is this is that total? I think this is total. This is not a correction. This is TSS. I'm wondering because so TSS. So TSS means it is yi square, right? We have a data for y, and you need to calculate sum of yi square. We'll get TSS. So what is your ESS from here? It is going to be r square into TSS, right? So r square into TSS. So TSS is summation yi square, and once we have ESS, one can get RSS using the total sum of square minus ESS. Okay, I don't know how much you understood using this all written part, but definitely if I'll create in a form of table, you'll be definitely understand. Okay, so let me create table. You'll become understand. So generally this we are doing a procedure of testing overall significance of the model. Okay. So under the assumption, say we are putting some assumption under the assumption beta 1 beta 2 is equal to 0. So what will be F ratio? F ratio is ESS by degree of freedom, which is 2, divided by RSS by degree of freedom, which is n minus 3, which follows F distribution with 2 comma n minus 3 degree of freedom. You can don't write degree of freedom because that is understood. and here we are testing h naught beta I is equal to 0 where I takes value 1 comma 2 versus h1 beta I is not equal to 0, or I can write h1 not h. Both will work here. Okay. Sometimes we write not h naught. Sometimes we write beta I is not equal to 0. So you should know both. Okay. So now we have here very famous unwanted. So 1, 2, 3, 4. We need just give me a minute. So this is due to okay. So here we have source of variation, right? We have source of variation which we called SP, and then we have a degree of freedom. Then we have a SS which is called sum of square. Then we have a mean SS. Okay. The first one is it is due to regression. Due to regression. Second one due to residual, or one can call error. And last one is the total. So total we have n minus 1 because n observation, so n minus 1 degree of freedom. We have two parameters to be testing here. See, before I told here it is 3. It is not 3. It is 2 because uh, it is beta 1 and beta 2. We have only two variables. We have only two variables, beta 1 and beta 2. So whenever you want to check the beta 1, beta 2, that means you have a due to 2 regression, and if you take a difference, it become n minus 3. Then we have a ESS here. Now, are you using the notation same here, which I'm using here? Because otherwise, you don't get confused. Here, are you using the same notations? Because here, this ESS is not error sum of square. This ESS is a regression sum of square. If I'm not wrong. So due to residual, I'm using RSS, and due to regression, I'm using ESS. So are you using same notations? Because I just want to extend the simple linear regression का concept continue. Otherwise it won't be, because if I use different notations, then it should match with your what is called your simple linear regression model. It should not.
Yes, sir.
Yeah. Okay. So this is ESS, which is R square summation of yi square, and this is RSS. This is 1 minus R square summation I takes value 1 to n yi square, and this is going to be some TSS, which is summation yi square. So if you just divide their degree of freedom, we'll get mean sum of square. If we divide this RSS by n minus 3, we'll get the residual sum of square. And based on that, what will be result? What is the conclusion? Reject H naught if f cal will be greater than f tag. What is your f tag? F 2 comma n minus 3 comma alpha. So alpha will be your how much percent of error will be there. Based on that you can calculate. And what will be f cal? F cal is equal to ESS by 2 upon RSS by n minus 3. Means one can create here f cal and f tab also. No problem. F cal and f tab, because it will take like two more entries. So if you just calculate this f cal, it will be ratio of these two, because it is mean sum of square due to residual due to regression upon mean sum of square due to residual. Will get f cal, that means this entry, and then need to calculate this entry, and we can get the answer for this. And we can write this result. If H naught is rejected, we conclude that beta 1 and beta 2 are are significant. That is, we conclude that explanatory variables have linear influence on dependency. So I think this is, and we know when ANOVA tables comes in picture and we put the conclusion, that means entire thing goes over, right? So let me know if you have any query related to this. I hope you have this gone through everything, that ANOVA table and everything in that unit 2, right? If you have any query, then let me know. I'll scroll it. So if you have any query. Yes, any query? Anyone? N minus 3 for RSS. N minus 3 for RSS. N minus 3. Let's see. Yeah, that means error, na? Yes. N minus 3 for RSS. Correct. And yes. Sony, which file you are like looking for me? Which file? This file, which I'm writing on the note, OneNote. Yeah, I'm going to upload. This is also in your Canvas. I'm going to upload in Canvas. But what I was thinking, that let me complete the at least half part of this. Okay. Otherwise, I have to upload this. Then I have to upload the extra also. Okay. So very soon I'm going to upload this one also on a Canvas. You don't need to worry about the notes. Okay. You will get everything, whatever I have, I will share with you in Canvas. Don't worry. Okay. So I think few parties remaining here. Let me finish maybe the hopefully the next lecture. Maybe the next if I get two more lecture, I will finish it this, and then this is going to be uploaded in Unit 2. Okay. So you can directly visit to Canvas, and you can watch this. You can I will, if you want, I can upload the video also. Video is also available on based on that. Even this you can say PDF file is also available in Canvas. Okay. Give me some time for uploading that. Okay, any other question is there now? Maybe any maybe silly doubt or any things? No doubt. Everything understood. Very nice. Jay sir has explained everything deeply, and so that's why I think there is no doubt. But I have one doubt. I have one doubt to all. Here in this ANOVA table, what you are testing? What is your test? Anyone? Anyone can tell. This is all you have seen in simple linear regression model. There were only one regression coefficient, that is your beta 1. But here we have more than one. Only difference is that. So you have already studied what it means. Okay. Significance. Yeah, significance of what? Right.
Parameter.
So you are testing both beta naught beta 1. Sony, you are testing both beta naught beta 1 or only beta 1?
Beta 1 and beta 2 as well.
Correct, correct. It's a beta 1 beta 2. Why not beta naught? Because beta naught is a constant value. Beta naught is a constant value. Because if beta 1 and beta 2, if the beta 1 changes, then only your dependent variable is changes. Or if a beta 2 will be changes, then only your dependent variable will be changes. So that's why we are always checking for slopes value. We are always checking for slope value, which is your beta 1 beta 2. That's why here we are doing the testing of regression coefficients, which is beta 1 beta 2. Is that clear? Not beta naught. Okay. One more question. In this ANOVA table, your name is ANOVA. ANOVA means
Analysis of variance.
analysis of variance. So, but here you are nothing doing with variance. Here you are nothing doing with variance. Where is your variance? Are you doing testing for variance? No. So here I am assuming that assuming the concept of variance. Assuming the concept of variance. If you see this, I have just given here one condition. Sigma hat. Sigma hat is your variance, right? Sigma hat square is a mean sum of square. It's a mean sum of square. And maybe you have studied the condition for variance. वेरिएंस का कंसेप्ट आपने assumption में क्या पढ़ा है आपने regression coefficient के assumption में क्या पढ़ा है you have studied some assumption of regression maybe related to R square something like that. So this entire ANOVA is based on your variance. Maybe I am assuming the variance is constant. Is there is a variability? The first column, if you see, it is showing the SV. SV means source of variation, right? SV means source of variation. So my entire variability, my entire variance is split into two parts. It's split into two parts. One will be due to regression, and other one will be due to residual. Okay, so total variation is split into two parts. So here your variability is splitted. So that's why variation is split. That's why his name is given ANOVA, analysis of variance. So variation is split. Are you getting? Here even you are not testing for mean. Here you are testing for betas, but still we write ANOVA. Right? So that one thing just I want to detail. And one can see here we are saying that here it is analysis of variance and we are testing for variance. That means I have to use F test. Remember, sometime it may be asked in your objective question. Analysis of variance means I am going to use F test. I am not going to use T test. Okay. T test is used only when you are comparing the two population mean or single population mean. Then only you can go for T test. And whenever you compare the variances, you can always go for F test. And the criteria is given to here. Reject H naught if F calculated value will be greater than F tabulated value. F calculated value which you can obtain using the data, and F tabulated value which you are going to use table and you can calculate those values. Okay. If F cal will be greater than F tab, then you are going to reject the null hypothesis. Okay. So that criteria is remain same even for you can called uh, mean. Okay. But what is the difference in mean? We know that for testing mean, your normal distribution is a normal. Okay. Normal distribution have a normal shape. So if it is now, since here you can say that we have testing for two sided, not for single side, not for single side. Because if it is one tail, then still the condition your condition is going to be changed in that scenario. Okay. So make sure that whenever it is two sided, you take mod of that in mod of t cal will be greater than equal to t tab, but only in the case of analysis of in that whenever you're comparing the mean. But here the criteria is going to be the same. You are not taking any mod and everything because it is a skewed distribution, right? It is the skewed distribution, and whenever this situation arises, you take something reciprocal of that. Maybe you're going to deal this all rejection and critical region maybe in your uh, testing. No, testing is there. Maybe testing will be next semester. Testing will be next semester. So you're going to you have all get you can call conceptual thing in your testing part. Okay. So you may understand this how this FCAL and FTAB work. So this FCAL will be the ratio of it's a ratio of two variances. It's a ratio of two variances. Always remember. Okay. So FCAL will be the ratio of two variances, and what about T? What about T calculated? T calculated it is basically ratio of mean. No, ratio of mean. No, we cannot say ratio of mean. T calculated is given some formula. Means you can if you consider a simple data and you're comparing for mean is equal to 0 or not, or maybe some other number, it is going to be x bar minus mu upon sigma by root n, right? So it's a difference from their population mean divided by standard error. Okay. So your T cal is a difference of a population mean. Difference of population mean. It's a ratio of difference of population mean to the standard error. That is your T calculated. Yeah, exactly. Difference upon standard error. Absolutely correct. Difference upon standard error. So just understand this all few terminology and basic concepts, because that is whole thing that is sufficient to understand the conceptual thing. Okay. And if there is no descriptive paper, then it is going to be helpful for those students like who bored about theory part. Okay. So they can understand the conceptual thing, like they can go for quiz, no problem. Okay, so this is from my side, my question, my doubts. Okay, any more questions, more difficulty or more doubts, so we can. Otherwise, I have completed the half part of this. So next time, maybe the next class, we will see that one more part, which is incremental contribution. So if instead of one variable, that is x1 I have, x2 I have, let me tell you what I'm going to do the next class. So incremental variable means if I increase the number of variable, means instead of beta 1 x1, beta 2 x2, and again some betas or maybe x2 x3 and so on. So is that my model is going to be significant or not? Is that my r square value is going to be increased or not? Okay, is that r square adjust will be increased or decreased? So increasing the variable or decreasing the variable, is there is any significant difference or not? Okay, that is my question. Okay, so hope you can understand the question. Means if I have this x1, this xi, because xi contains so many observation, x11, x21, x31 and so on, right? If I'm considering only these many observations and I have done everything, all derivation, I know everything, what is my output? And if I increased by this quantity x11, x21, x31, x41, x51, if I increase this data, or it will be x11, x21, if I reduce this data, okay, if I reduce this data, then what is my significant on my model? Is that r square value increase or r square value decrease? Is that is significant or not? Okay, so that is all we are going to discuss in the next class, which is called as incremental contribution. Okay, so whenever there is a more increment in your variable, then what is going to be effect in my model? Okay, so this was the last, maybe the next session. So if you have any query, you can ask, otherwise you can stop. Yes, no question? Let's remove this and then we can end the session. So start preparing for new units, and very soon I'm going to upload this in. I think I am already uploading these videos on YouTube. You can just watch the video for a being. By the time I will finish this, maybe the writing part, and then I will upload it in Canvas. Okay. Chi square के बारे में भी बताइए सर. क्या? Chi square क्या होता है? Okay, we will. I think that we will discuss. Just remind me. We will discuss in the next class. Okay, and then we will see in the session. So have a good day and enjoy the day, because
Thank you, sir.
tomorrow is no lecture. So I hope you can look into Canvas. Thank you.
Thank you, sir.